when we're doing like 22, you don't have to put the 1 times 1.
You don't have to, because it really is just the same thing.
Okay.
It's kind of redundant. So on 8, it says, in poker, a person is dealt 5 cards from a standard 52-card deck. The order in which the 5 cards are received does not matter. How many different 5-card poker hands are possible?
Well,
so
this one's kind of hard because if it's talking about like the rules of poker, it's only assuming certain hands that you possibly have.
that's true. So there are, when you're talking about poker, there are only certain hands that actually have value to them or can be a winning hand. That is absolutely true. But in this case, we're just wanting to know how many different possible hands you could have, 5-card hands. Yeah, exactly. So
That kind of works.
in this case, we're picking from a 52-card deck. So they're saying 52 a standard. You can actually have decks that are of a different size than 52, but that only works for certain games. And we're just looking at the standard 52 cards. And then we're picking 5 cards from that deck. So N would be 52, R is going to be 5. So writing this out, our NCR is going to be 52C5. So we talked about the NPR function in the calculator yesterday for permutations, or Tuesday, sorry. Today we're going to be using the NCR function if you're looking for combinations. So it's under the same thing as the factorial and the NPR. It's under that math button. If you go over, there's going to be a P to the PRB menu. Go down. You have NPR, NCR, and then the factorial. We're going to use the NCR function. But one thing that's different about setting the NCR up is that unlike a lot of functions in the calculator, except for like multiplication, addition, subtraction, and division, you actually have to have a number in front of it. So it put this answer over here because it was trying to put a number in front of it. So for this problem, I have 52C5. So I'm going to type in 52, go to math, go over to the PRB menu. I'm going to go down to NCR, hit enter. So I'm going to have 52 NCR, and then I need to put my R, which is 5 for this. Hit enter. That's going to give me my number of combinations, which in this case is 2,598,960.
So that just solved that problem?
Mm-hmm.
Oh, this makes
860, you said?
2,598,960 is our total number of
So
combinations.
it's not going to be the same if we make it longer?
It would come out to be the same. If we expanded it out,
It would?
come out to be the same thing. So this is the calculator short root.
Oh.
So if we go, so for instance, let's go back to the first one. I'll do the first one on the calculator.
Basically use that for all of them.
For most. So a good example of one that you can't use, so this actually goes with permutations. On the permutations one, if you have duplicate letters, so that what we talked about today, you couldn't use the function in the calculator because that does not account for duplications.
Well, what about the NCR?
So-
Would that be used for every single one?
For all of the ones that you're going to be working with today, yes. But sometimes you actually, and that's where 9 and 10, we're not going to talk about those today, but 9 and 10 on there, they actually have multiple pieces to them. We're going to talk about that on Monday, though.
That's
Yes.
what I was going to ask you. I was like, do you have to do 2 different?
Yep, 2 different ones and you multiply them together. Yep.
If we wanted to.
If you want to work on, that's fine. So just to show you that this does come out with the same answer if you had expanded out, let's look at the previous one, that 22C3. So I'm going to put 22, go over to math, PRB, NCR. So 22 NCR3, if I hit enter, it's going to come out to be that same 1540 that I found from expanding it out. Any questions?
Why didn't you show us this before?
Because I wanted you to see what was actually happening.